Section 3.4, perpendicular lines. So looking particularly at lines that intersect at 90 degrees. We're going to take a little bit of a detour to look at this a little more in depth. Now, a perpendicular bisector to a line segment does exactly those two things, okay? They're not trying to hide anything or make it ambiguous. It's perpendicular, so it intersects at a 90-degree angle, and it bisects, or cuts into two congruent pieces. Now, additionally, if you want to get from a point to a line, the quickest way to do that is to go perpendicularly towards the line. All right? So we'll follow a path that is perpendicular. That's just something I want to put out there so I can say that I said that. All right? To get to a surface or a line as quickly as possible, head directly for it perpendicularly. So some interesting theorems that we get from these perpendicular relationships. And I have some shorthand over to the right that we can utilize. But two lines intersect, they form a linear pair. That always happens. Two lines intersect, there's always going to be linear pairs. If the linear pair of angles are congruent to each other, then those lines are perpendicular, which makes sense. If the linear pair is congruent to each other, the two angles add to 180, but they're the same measure, well, they both must be 90 degrees. In a plane, if a transversal is perpendicular to one of two parallel lines, then it must be perpendicular to the other, which kind of makes sense. These lines are parallel. Angles 1 and 2 are corresponding, so they must be congruent. If angle 1 is a right angle 2 must also be a right angle. And then kind of the reverse of that. If two coplanar lines are perpendicular to the same line, then the two lines must be parallel. So you have angle 1, angle 2. They're both 90 degrees. They're congruent. So by the converse of the corresponding angles postulate, R and S are parallel to each other. So let's take a look at how we can use those with example 1. So let's get my table. So angle 1 is congruent to angle 2. Line P is perpendicular to line Q. So let's mark up my diagram. 1 and 2 are congruent. P is perpendicular to Q. So now prove that P is perpendicular to R. Well, let's use my givens. All right, I have that 1 and 2 are congruent. 1 and 2 are both in the bottom right of their intersections. That means 1 and 2 are in the same location as each other. They are corresponding angles. If the corresponding angles are congruent, then the two lines must be parallel. So R is parallel to Q by the converse of the corresponding angles postulate. So now we know that R and Q are parallel. And we're trying to get P perpendicular to R. Well, let's look at what we have. We have parallel lines. P is perpendicular to one of them. So if the transversal is perpendicular to one, it must be perpendicular to the other. So that means that P is perpendicular to R by the perpendicular transversal theorem. So just trying to get the hypothesis to make the appropriate conclusion. Okay? Let's take a look at one more. Let's go down to example 2. So we have R is parallel to S, and angle 1 is congruent to angle 2. Given information. So R is parallel to S, and angle 1 is congruent to angle 2. So we want to prove that R is perpendicular to T. Well, let's use our givens. Okay, first, R is parallel to S. So we have R and S. I see that I have an angle pair, angles 2 and 3. Those are corresponding angles. Because the lines are parallel, that means angle 2 is congruent to angle 3 by the corresponding angles postulate. So let's get a different color in there. Now, this is a move we've seen before. 1's congruent to 2, 2's congruent to 3, so it makes sense that angle 1 is congruent to angle 3 by some substitution. I'll go ahead and use substitution this time. Shake it up a little bit. So 1 is congruent to 3. Now 1 and 3 form a linear pair. They're adjacent, next to each other, and they form this straight line. But they're also congruent to each other. Now if their measures are the same, and they form a linear pair, that means they add up to 180 with equal measures. Well, both of them must be 90 degrees. So that means that R is perpendicular to T by, let me just check the name to be sure. Yep, perpendicular. Oh, now I gotta line it up. Aha. By the perpendicular linear pair theorem. One more example, example 3, you can take a look at that. Check my completed notes online, see how you did with it.